After compiling any Java program, we are going to get bytecode. So when I call this line, it is going to return the length of the argument. Now what is this args? That is nothing but the command line argument variable. What is compile time binding? That is nothing but the compile time linking. That means it's going to link all the properties during the compile time. Hello to all, a warm welcome to my new session on Java evolution. I am Revati from the Department of Computer Science, Vidhyaashram, First Grade College, Temple of Excellence, Mysuru. So dear student, before going to start my today's session, let me to recall the things what I have discussed in my previous session of this chapter. So in the previous session, I started with what is Java token. Along with that, I have covered Java statements as well as how to create simple Java program. But in my today's session, I'm going to deal with Java virtual machine, command line argument as well as object-oriented programming methodology in Java. Now, let me to start with the topic that is Java virtual machine. So dear student, please make a note here. This is very important topic. So it is also called JVM. So Java virtual machine. Now, as the name itself indicates that it's a machine, but it is not physically present, but it is logically, it is nothing but the simulation of execution of computer environment. Now, Java compiler produces an intermediate code. Dear student, as we know that Java compiler generates intermediate code and it is called bytecode. Because of this bytecode, Java is called platform neutral or platform independent. Now just imagine here, the name of the program is Java PRG. After compiling this Java PRG, I'm going to get bytecode. So after compiling this program, I'm going to get bytecode for a machine that does not exist. Now, just listen here. My program is Java PRG. After compiling this program, I'm going to get bytecode. And now tell me to which system I'm going to provide bytecode as input. For that, here we are having Java virtual machine. After compiling any Java program, we are going to get bytecode. And this bytecode is input to the Java virtual machine. Now tell me, what is this Java virtual machine? So what is virtual? It's logically present but physically not present. I'm going to get same working environment, but it is not physically present, but it is logically present. This machine is called Java virtual machine and it exists only inside the computer memory. That is nothing but the simulation of execution and it is present in the computer memory, but it's not physically present. I repeat, it is a machine. It's a machine and it's called Java virtual machine. It's nothing but the simulation of an execution of Java program. And it exists only in the computer memory or only inside the computer memory. Now, let me to consider this example. So, what is my source code? That is nothing but the Java program and this is the input to the Java compiler. Now, what is the input to the Java compiler? That is nothing but source code. Now, what is the job of the compiler? Now, convert or translate the Java program into bytecode. Now, Java compiler generates bytecode. Bytecode, and this bytecode is the input to the virtual machine. So, what is the input to the virtual machine? That is bytecode. Now, what is Java virtual machine? It is a simulated computer. So, it is a simulated computer within the computer which does all the major functions for the real computer. So, here Java virtual machine is nothing but the simulation, and it is responsible performing all the major functions for the real computer. So, the Java virtual machine code is not machine detailed. So, whatever the virtual code, that is byte code we are going to get, that is not the machine detailed. Now, what's the input to the virtual machine? That is the byte code. Now, whatever the output I'm going to get from the virtual machine, that is the input to the Java interpreter. Now, Java interpreter converts that into machine code. Now, if I consider Java program, I'm going to have Java compiler. Java compiler generates bytecode, and that is the input to the virtual machine. Now, after this virtual machine, whatever the output I'm going to get, that is the input to the Java interpreter, and Java interpreter generates executable code, and it is called machine code. So, the machine specific code is generated by the Java interpreter by interacting as midway between the virtual machine and the real computer. To generate machine code, I require Java interpreter, and it acts like a mediator between virtual machine as well as that is real computer. So dear student, let me to explain command line argument. So what is this command line? Where I'm going to provide the command line, or where I'm going to provide the input in my command line. Along with my program name, I'm going to specify the input. Now, if I consider Java program, how to compile Java program, that is Java C, and specify the file name. Now I'm going to run the Java program. For that, I'm going to write Java. Along with that, I'm going to specify file name. Then I'm going to pass the argument. So this kind of input passing is called command line argument. So along with my file name, I'm going to pass the input. Now, this is the simple example for command line argument. And dear student, from the examination point of view, this is very, very important. Now, it carries 7 or 8 marks. That means you can able to expect this question for 7 or 8 marks, and it is very, very important topic. Now, let me to explain this program. So, at the beginning, I'm going to have my class name. Then, here I'm going to have my main program. So, I'm going to write the main program inside the class, and I'm going to take two integer variable count and I, and I'm going to take string variable. So here string is my data type and the name of the variable is string. Now I'm going to call count args So I'm going to call count equal to args of length. So when I call this line, it is going to return the length of the argument. Now what is this ARGS? There is nothing but the command line argument variable. So this is the variable used to receive all the command line argument. With the help of this variable, I'm going to call the method length, and it's going to return the length. So what's the length? It is 2. Now I want to display the message, that is the number of arguments present is 2. So the number of argument present here is 2. Now I want to read the value one by one. That means I want to display the value one by one. I'll use while, or even I can able to use for loop. So what I will do, I'll start with the for loop. For I equal to 1 semicolon, I less than or equal to count I plus plus. Then what I want to do? I want to display the argument one after another. So I'll write system.out.println. Then I want to display the argument. So what I will do? I'll write args equal to, I'll write args of I. Okay, now I'm going to close this one. Now I less than or equal to 2, it is true. So the control enters into for loop. Now I'm going to print args of I. That is, I'm going to print num. Now I'm going to increment I by 1. Now I is 2. Now 2 less than or equal to 2, it is true. So what I will do? I'm going to print the value, that is argument man. Now I is incremented by 1. Now I is 3. 3 less than or equal to 2, the condition gets failed. So the for loop comes out of the loop. Here the while loop comes out of the loop. Now let me to consider another example here. For example, I'm going to specify the argument ABC. I'm going to specify the argument ABC, and this is the command line argument. Now tell me how many times this for loop is going to execute. 3 times, and it's going to display ABC. It's going to display command line argument A, B and C. Now let me to explain another topic, that is object oriented programming methodology in Java. In that first topic, I'm going to have inheritance relationship. So what is inheritance? So two different classes are in inheritance relationship when the subclass is a kind of superclass. Now what is inheritance? Inherit the property. For example, think that if my parents own some property, then automatically I can able to inherit or acquire that property. And for example, if my grandfathers own some property, then that same property is acquired by my parents, and I can able to acquire that property. So this kind of relationship is called inheritance. Now, if I want to make use of same function, or if I want to reuse the existing thing, then I can able to go with the inheritance. So the very important concept of object oriented programming language is inheritance. Inherit or acquire the property or features of other class. So, two different class are in inheritance relationship. For example, if I am having class A and class B. Okay, if class B inherits all the properties of class A, then it is called inheritance relationship. That means this class B can able to acquire all the features of class A. Now, inheritance is compile time binding between the class. So, what is compile time binding? There is nothing but the compile time linking. That means it's going to link all the properties during the compile time. So, this is the first feature of Java, that is object oriented programming methodology in Java, that is inheritance relationship. Now, let me to consider another relationship, that is association relationship. Now, an object-oriented programming on object uses the functionalities of other object. So, one object can able to use the features or functionalities of other object. That is called associativity relationship. That means there is a relationship between one object to another, and there are four different kinds of relationship, that is one to one, one to many, many to one, and many to many. Let me to consider one simple example here, that in one college, I'll specify. So one college, there are n number of department. So one college, n number of department, one to many relationship. And if I consider department, I'm going to have n number of student. So in n number of department, n number of student, and each student or different student will have unique roll number. So there are 100 students and each student will have unique number. Or I can able to consider another example, that there is one prime minister. So for one prime minister, there are n number of minister. And if I consider minister, there are many MP. Similarly, if I consider object-oriented programming concept, then we are going to have association relationship. That is nothing but the relationship between the object. And there are four type of relationships, that is one to one, one to many, many to one, and many to many. And if I consider this example, employee uses smart card to mark the attendance. So one employee is going to use smart card to mark the attendance. So one to one relationship. So dear student, if I consider same employee with bank card, now the same bank card is used to do online shopping, or to draw the amount, or to pay bill. So this is one to many. Like that, if I consider Java, we are having association relationship. Now let me to consider another methodology, that is aggregation relationship. So what is aggregation? It is a container. So it is a container relationship where an outer class contains inner class. So once again, it is mainly dealing with the association relationship between the outer class as well as inner class, and both the classes are differ each other. So one is inner class and one is outer class, and both the classes are differ from each other. and both class or both entity, they have their own lifetime and they can exit independent of each other. That means both outer class as well as inner class does not depend on each other, and these both are independent entity. For example, department has student. If I consider individual department, they are independent to each other. That means they are not depending each other, and each department has their own student. This is the example for aggregation relationship. Now I'm going to have composite relationship. So what is composition? It is a container relationship that indicates whole part relationship. So there is a whole part relationship between outer class as well as inner class, and they are fully dependent each other. Suppose if they want to perform any action or any activity, both the classes are dependent each other, and that is itself called composite relationship. So the whole part cannot exist without inner part of object. So here both the classes are dependent each other. Without any one class, it's not possible to perform any activity or any operation, and they are fully dependent on each other, and it is called weak form of association. So once again it is relation. So it is relationship between the object, and each objects are dependent on each other, and this is the example for weak relationship, and it is going to happen only during dynamic binding or runtime execution. And example, human has a brain. So without brain, human cannot able to think or cannot able to perform any activity. Even human being cannot able to make the decision. So here human beings are fully depends on the brain. So brain as well as human being or brain, both are dependent each other, and this kind of methodology is called composite relationship. This is all about object oriented programming methodology in Java. So dear student, I hope in my today's session you got more information about Java virtual machine as well as command line argument, and the different kinds of methodology comes under Java. But in my next session, I'm going to deal with constants as well as variables. So dear student, don't miss to watch my next session, because there I'm going to deal with constants as well as variables. So dear student, thank you for watching my session. Let's meet in the next session with some more information about Java evolution. Until then, keep learning and keep watching. Thank you.